Okay, guys, welcome. Today we're going to talk about ways to measure variation. Now, first, before we get into that, we're going to talk about, well, why does variation matter? And we're going to use the following motivating example. Now, consider a bank that delivers service to customers over a wider spread time as opposed to one that has a more narrow time spread. Now, if the mean and median are the same, how does variation play a role in this scenario, right? So let's say that the mean and median wait time is, say, 3 minutes. Now, if you have large variation, waiting 15 minutes will be more common. So the mean and the median being 3 minutes might not mean much to you if you know that there's a large variation. If there's a small variation, then waiting 15 minutes is going to be a lot less likely, and you realistically would be waiting maybe 5 minutes would be an unusual, right? So it's important to consider the variation when you're looking at different scenarios. Now, the most simple way to measure variation is to find the range. And of course, that's just the difference between the highest and the lowest value. So this, of course, is nice and easy to compute, but it's a lot of times misleading and doesn't really tell the whole story. So for this first example, we're going to consider the following two sets of quiz scores for 9 students, and we'll talk about which set has the greater range, and we'll also comment on would we say that the scores in that set are more varied. Now for quiz 1, right, remember that the range is the largest value minus the lowest one, so it would be 10 minus 1, so we get that the range is 9. Now for quiz 2, the range is going to be 10 minus 2 this time, which is 8. Now, of course, we would probably not say that quiz 1 is more spread out, right? Because most of the grades here were 10, right? But we would probably say that this is more spread out. So that's why the range can be somewhat misleading, right? So that's one thing to keep in mind. So let's talk about one that's better, right? So we can talk about the 5-number summary after we talk about what quartiles are. Now, quartiles are numbers that divide the data distribution into quarters, right? So we're given this data set here, and the quartiles are bolded, right? Now, the middle quartile is simply the median, right? If you were to cross off low, high in this data set, you would get that 7.2 is your median. Now, of course, where the other quartiles come from, well, just keep in mind that this is the median. Well, if I look at these now separate data sets, 5.6 is the median of the lower part, and 8.5 is the median of the upper part, right? So this is your lower quartile, and this is your upper quartile. Right, so that's how we find those. Right, so just to recap, the lower quartile, or sometimes it's called the first quartile, divides the lowest fourth of a data set from the upper 3/4. And of course, we just saw that it's the median of the data values in the lower half of a data set. And if you're confused about whether you should include or exclude the middle value, and the last one we didn't include it, and that's because the number of data points that we had was odd, right? So we have 11 data points in this section, in this data set right here. So we don't include the median when we break it up into lower and upper quartile, right? And of course, the middle quartile we said is the median, and then the upper quartile is just the opposite of the lower, right? It divides the lowest 3/4 of a data set from the upper fourth, and it's the median of the data values in the upper half of a data set. And again, we would exclude the middle value if the number of data points is odd. Okay, so let's first take a look and see how many data points we have for this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have an odd number of data points. So when we go to calculate our lower and upper quartiles, we'll exclude the median. All right, well, first let's find the median. So if I cross off low, high, until I get one left, it looks like our median is going to be 15. Okay, now let's get rid of this, and let's find our lower and upper quartile. So let's find the lower. Now again, remember that since we had an odd number of data points, I'm not going to include 15, and I'm just going to look at these, right? So now I have, let's see, wait a minute, did I count this right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, no, I did count this right. So if we exclude 15, then we have cross off 3, 12, 4, 10, and then we have 7 and 8. So it looks like my lower quartile is the median of, or the mean of those two, so 7.5. Then if we look at the upper section, upper quartile, well, we cross off 18, 33, 22, 31. And if I take the mean of 25 and 27, I would get, sorry, 25 and 29, I would get 27. All right, so those are our different quartile values for this data set. So now we've talked about the quartiles, and we can now use this to talk about the 5-number summary. Now this just is summarized by the lowest value, then the lowest quartile, median, upper quartile, and the highest value. So as an example, let's go back to our last slide. And for our 5-number summary, we just need to include the low value and the high value. So in this case, the low value is 3 and the high value is 33. So with this information, your 5-number summary would be in order 3, 7.5, 15, 27, 33. Right, where as we go left to right, we have low value, lower quartile, median, upper quartile, and high value. So that's our 5-number summary for this data set. So even though it's a little bit more complicated to find, it's definitely much more telling of the entire story than the range, right? Because for a range, you would just get 30. Now, once you have the 5-number summary, you can then draw a box plot, right? So to draw a box plot, first you're going to draw a number line that spans all the data values in the set. Then you would enclose the values from the lower to upper quartile in a box on that number line, draw a vertical line through the box at the median, and then you'd add a straight line that extends from the lowest to the highest data value. And we're going to do an example of that. Now we'll just do that with one of these data sets because these are a lot of data points. And we're going to consider the following 2 sets of 20 10-meter running times, right? So let me cross out this section 2. Right, and if you wanted to do that, you could just rewind it a couple seconds and pause it, and you can try this for that second data set. But for the time's sake, we'll just do the one. Now we see that we have 20 data points. So when we find our lower and upper quartile, we will need to use the median in our group. All right, but anyway, let's find the median. Right, so if we want to do that, I'm going to cross off low, high until I can't anymore. And I think these are all in order. Okay. And then it looks like we're left with 10.13 and 10.14. So my median is going to be 10.135. Right? If I average those together, I'll get 10.135. So now sort of I'm going to have this as one data set and this as the other data set. And we can now find the median of those two. All right, so if I do the first one, that will be my lower quartile. So if I find the median of this data set, I'm going to get low, high, low, high, low, high, low, high. And then we're left with 10.06 and 10.07. So it looks like my lower quartile is 10.065. All right, and then do the same thing for upper. If I go low, high, looks like we're going to end up with 10.18 and 10.21. So if we average those together, we'll get a 10.195. And then, of course, we can say that our low and our high value are 9.92 and 10.38. Okay, so your 5-number summary would be 9.92, 10.065, 10.135, 10.195, and then 10.38. Okay, now as a box plot, here's what we got to do. So there's my number line. And let's say maybe I have something like 9.9 here, because that would be lower than all my data values. And then let's say we have 10.4 up here. Right, and then if I fill in some hatch marks, we could say this is 10, this is 10.1, this is 10.2, and this is 10.3. Well, we need to draw a box around where our lower and upper quartile is. So I need to go from 10.065, so that's maybe somewhere around here, to 10.195, so to about here. Okay. Now I draw a line through the median. Well, the median was at 10.135, so that would be something like right about there. And then I need to draw a line from my lowest to my highest value, so 9.92 to 10.38, so something like that. Right, and that's what we would get from a box plot. So you can quickly see where most of the data values are clustered. You can see where the median is, and then you can see the range of all the values as well. All right, so that's what we do when we calculate a box plot. Now, the 5-number summary does a good job when it's describing the variation, but statisticians prefer to describe variation with just a single number. And the number that's most commonly used to do this is what's called the standard deviation. Now, to find the standard deviation, here's what we would need to do. So we would need to compute the mean of the data set, and then we find that what's called the deviation from the mean for every data value set. And what that really just means is you're finding the distance from each data point to the mean. Then you're going to square all of those numbers, then add all those numbers, and then you're going to divide that by the total number of data values but -1, and then you're going to take the square root of that. All right, so let's go ahead and we'll do that. So first, I need to find the mean and then the standard deviation, and find the deviation. So first, find mean. Well, in this data set, I need to do 3 plus 7 plus 4 plus 8 plus 10, which if I do that, let's see, I'm going to get a 14, 22, 32 divided by 5. So we get a 32 divided by 5. And then that will give us, let's say, a 6.4. Right, 5 goes into 32 6 times with 2 left over, so we get 2 out of 5, so 6.4. So now we need to find the deviations from all the means. So if I look at 3, 7, 4, 8, and 10, how far are each of these away from 6.4? Well, 3 minus 6.4 would be a negative 3.4. 7 minus 6.4 would be a 0.6. 4 minus 6.4 would be a negative 2.4. 8 minus 6.4 would be a 1.6. And then 10 minus 6.4 would give me a 3.6. So now these are all of my deviations from the mean. So now in the next step, we add all these together. Sorry, we don't add them yet. We square them first. So square all these so that they're all positive numbers. So if I square 3.4, I'm going to get 11.56. Right, that was negative 3.4 squared. If I square 0.6, I'm going to get a 0.36. If I square negative 2.4, I'm going to get a 5.76. If I square 1.6, I'm going to get 256. And if I square 3.6, I'm going to get 1296. Okay, so those are now my squared deviations. So now we add them. So we get 11.56 plus 0.36 plus 5.76 plus 2.56 plus 12.96. So if we add them, plus 5.76 plus 2.56 plus 12.96, we get 33.2. Then next we divide this by number of data points minus 1. So we have 5 data points, so I need to divide this by 4. And that would give me an 8.3. And then finally, we square root this. If I take the square root of 8.3, I'm going to get that the standard deviation is about 2.88. And of course, the higher this number is, the more variance you have in your data, and the closer you are to 0, that would be no variance, right? So here, the standard deviation is 2.88. Now, the standard deviation is, it's a little cumbersome to calculate. So one thing that we can also do that's, of course, not as accurate, but it's approximately related to the range of a distribution is another way to get the standard deviation. And that's just take the range divided by 4. And a lot of times this is fairly close to the standard deviation. Now, if we know the range of a data set, you can use this rule to estimate the standard deviation. And you can also use the standard deviation to estimate the range if you wanted to as well. Okay, and then you can also, of course, use the standard deviation to estimate the low and the high values, right? So the low value would be the mean minus 2 times the standard deviation, and the high value you could estimate would be the mean plus 2 times the standard deviation, right? Now, of course, this rule won't work well if you have outliers as your high or low values, but that's the way that we can sort of use that. Now, if we use the range rule of thumb for the example that we just did, right, what would the range of this data set be? Well, the range would be 7 because it would be 10 minus 3. And if we do 7 divided by 4, that would give you a 1.75, which is okay. All right, that's not the greatest demonstration, but it gives you a quick number that approximately gives you the standard deviation. Okay. Now, in this next example, we have that the studies of gas mileage of a Prius under varying driving conditions show that it gets a mean of 45 miles per gallon with a standard deviation of 4 miles per gallon. So, of course, if we wanted to estimate the low and high values of the minimum and maximum, well, the minimum is the mean, so 45 minus 2 times the standard deviation, so 45 minus 8, which would be a 37. And then the maximum would be the mean plus 2 standard deviation. So plus 2 times 4, so 45 plus 8, which would be 53 miles per gallon. So those would be the minimum and maximum gas mileages that you could expect under normal driving conditions. Okay, so that concludes this video on measures of variation. I hope you enjoyed, and I'll see you next time.